In the parallelogram ORST, points A and B lies on the side OR and OD respectively, such that OR equals to 2 times OA and OD equals to 3 times OB. Prove that the diagonal OS divides the segment AB in a ratio of 3:2, while being divided by segment AB in a ratio of 1:4. Let's try to understand it graphically first. So here we have a parallelogram with vertices O, R, S, T. Then it's given here that point A lies on the side OR. So A is going to be lying on side OR, and other point B is going to lie on the side OT. And the position of A and B is very important. It's chosen, point A is chosen in such a way such that if we take 2 times OA, that becomes equals to OR. In other words, we can say that A is bisecting OR, or we can say A divides OR in the ratio 1:1. Then point B is chosen on the side OT in such a way such that if we take 3 times of OB, this will be equals to the length OT. In other words, we can say B is dividing OT in the ratio 1:2. Fine. Now we need to prove that the diagonals, OS is the diagonal, it divides this segment AB in a ratio of 3:2. So we need to show that. Let's call this as the point C. So let's say C is going to divide AB in the ratio 3:2, and it is itself getting divided in the ratio of 1:4. So OC, the ratio of OC to that of CS is going to be 1:4. Okay, let us begin. Now we need to define the position vector of the vertices. So what we'll assume? We'll assume that the O corresponds to the origin. So let's say if it is the origin, then this position vector is simply going to be the null vector 0. With respect to origin, we're going to consider the vertex R to having a position vector of A and T having a position vector of B. That means we have let OR vector, let this be A vector, OT vector, so this is going to be B vector. Now using these 2 vectors, we can also find out the position vector of S, because what we can do here, we can consider OR vector added to RS vector, and this is going to give us the diagonal OS vector. So that means OS vector is going to be OR vector added to RS vector. So what is RS vector? That's equivalent to OT vector. So we have OR vector plus OT vector. OR vector means A vector added to OT vector, so that's B vector. Now that means the diagonal OS vector is going to be the sum of the position vector of A and B. So let's note that down. We'll be using it. So we have A vector plus B vector. Fine. Now what we'll do? We'll find out the position vector of point A, because A is dividing OR in the ratio 1:1. That means let's say here, since A divides OR in the ratio 1:1, and so 1:1, this implies that OA vector, that this will be equals to 1 times A vector added to 1 times the null vector divided by 1 plus 1, which is going to be simply A vector over 2. And then we can also find out the position vector of point B. So here B divides OT in the ratio 1:2, which then means OB vector, position vector of point B, so that's going to be 1 times B vector added to 2 times the null vector divided by 3. So that means we have B vector over 3. Now let's suppose we're going to make a supposition here. Let C divide the diagonal OS in the ratio lambda is to 1 minus lambda internally, so that we can apply the internal section formula. Now we're considering our lambda is to 1 minus lambda, so that means if we consider the entire length OS to be 1 unit, then if OC is lambda, then the remaining portion C is going to be 1 minus lambda. This is our ratio, which means that if we apply the internal section formula, then position vector of point C, that's going to be, we have lambda multiplied to the position vector of S, which is A vector plus B vector, added to 1 minus lambda multiplied to position vector of the origin, so that's the null vector, divided by lambda added to 1 minus lambda, and that's going to give us lambda times A vector plus B vector. Okay, let's label this as number 1. Now, again, we can define the position vector of point C in terms of A and B. We will suppose that let us C divide AB in the ratio m is to n, which means that the position vector of point C will be OC vector. So we'll start with m. M will get multiplied with the position vector of B. So position vector B, I already obtained that value as B vector over 3. Added to n times the position vector of A. So we have n times A vector over 2 whole divided by m plus n. Now let this be equation number 2. Now since A, B and OS intersect each other at point C, so we can say that C is the common point. In other words, we can say that from equation 1 and equation 2, so from 1 and 2, we have lambda multiplied to A vector plus B vector. So this is going to be equals to m times B vector over 3 added to n times A vector over 2 whole divided by m plus n. Okay, so let's try to arrange the terms. Where on the left hand side we have lambda times A vector added to lambda times B vector. So that will be equals to n over 2 times m plus n. So that will be multiplied to A vector added to m over 3 times m plus n. So this will be multiplied to B vector. Now, we can equate both sides. So equating both sides, we get lambda. This is going to give us lambda equals to n over 2 times m plus n equals to m over 3 times m plus n. So let's use these two ratios. So from these two ratios, we can get m over n. So this is going to be equals to 3 over 2. So here we have successfully showed that point C divides AB into ratio 3 is to 2. So from here we have C divides AB in the ratio 3 is to 2. Okay, now we need to find out the value of lambda. So let's try to find out the value of lambda. So let's consider now, let's say lambda equals to n over 2 multiplied to m plus n. We're going to rearrange this. So here we have m plus n over n. That will be equals to 1 over 2 lambda. Now, what is m over n? So here we have m over n added to 1 equals to 1 over 2 lambda. So we have already found out the value of m as to n. So that's 3 over 2. We have 3 over 2 added to 1. This is equals to 1 over 2 lambda. So 3 half added to 1, that's 5 over 2. This will be equals to 1 over 2 lambda. So that means lambda comes out to be 1 over 5. Okay, now that we have lambda equals to 1 over 5, this implies that 1 minus lambda. So that's going to be 1 minus 1 over 5. So that 4 over 5. So here, since we considered OC to be lambda and C is to be 1 minus lambda. So we can say here that C is going to divide the diagonal OC in the ratio lambda. So lambda is 1 is to 5 or 1 over 5 to that of 4 over 5. So what we can do, we can simplify this ratio to get 1 is to 4. So here also we have shown that C divides OS in the ratio 1 is to 4. With this, we have successfully proved the problem.